Hey guys, in this video we're going to be taking a look at Taylor series, so specifically the Taylor series for y equals cos x. So a Taylor series is pretty much an approximation of a function using polynomial terms. So the formula for a Taylor series is if you have y of x, the Taylor series for that is going to be y of x sub 0 plus y dash of x sub 0 multiplied by x minus x sub 0 plus y double dash x sub 0 all over 2 factorial multiplied by x minus x sub 0 all squared, and this goes on forever. So just to simplify, I'm going to go plus a sum starting from n equals 3 because that's where we're up to, and you can go on forever if you want to. Y to the n derivative, so this means derivative, so these dashes represent derivative, so this is the first derivative, second derivative. Once you get higher than a third derivative, you start putting a number up here in brackets, so this represents the nth derivative multiplied by x sub 0 all over n factorial multiplied by x minus x sub 0 all to the n. Okay, so this here is the formula for a Taylor series. As x sub 0 gets closer to 0, the more approximate you get. So for example, if we let x sub 0 just equal 0, in this case, let's find the Taylor series for cos x. So this here is just going to be cos x, so we'll just label that. So y of x sub 0 is just going to be cos sub 0. Y dash of x sub 0, if you differentiate cos, it's just going to turn into negative sign. So it'll be negative sine x sub 0. Yep. And then if you go y double dash, the second derivative of that is going to be negative cos. So that's going to be negative cos x sub 0. Okay. Now that's all we're going to use, and we're just going to leave this term at the back because you could go on forever. Because if you go on forever, the more approximate you'll get. So x sub 0 is 0, so if we put in 0 into here, this is going to be cos of 0, so that's going to turn into 1. If you put in 0 into here, that's going to turn into 0. If you put 0 into here, that's just going to be negative 1. So let's put that into our little Taylor series. So y of x is going to be x sub 0, which is 1, plus the first derivative, which is 0, multiplied by x minus 0, plus the second derivative, which is negative 1 over 2 factorial multiplied by x minus x sub 0 all squared. Oh, x sub 0 is 0. So that's just going to be just x squared. So we can rewrite that as just negative x squared plus, and then you've got all these terms here, which we will leave. So there will be a general pattern to this one here. So if you were to keep going with this sum here, you would get a particular pattern like this. So y of x is going to be 1 minus x squared on 2 factorial. Just so we can see the pattern, let's find another term for this. So let's just extend this. So let's just say, let's do 2 more terms. So let's go n equals 5, and let's add in a couple more terms here. So the third derivative, so 3, is going to be, if you differentiate this, it's going to turn into sine x of 0. The fourth derivative of that is going to be cos x of 0. So if you put in x of 0 equals 0 into here, that's going to be 0. This here is going to be 1. So what we have here is pretty much, well, it's going to be the third derivative, so we'll just write it like this. Third derivative x sub 0 on 3 factorial plus x minus x sub 0 cubed. I'm going to move to the side real quick so we have enough room. And I'm going to move this to the side, plus the fourth derivative multiplied by x sub 0 all over 4 factorial. Oh, that's multiply, sorry, that's not a plus. Put that together. Multiplied by x minus x sub 0 to the 4. And then we've got all these terms here. So now we've got the fifth order, and it goes on forever. So I can move that a bit closer if I need to. Now let's see if there's a rough pattern we're going to see. So now we've got to put in x sub 0 into these terms here. So we agree that this here, this third derivative, x sub 0, is just going to be for, this one is going to be 0. So that term is gone. This here is going to be 1. So that's going to be, simplifying this will just be x to the 4 over 4 factorial. And then a pattern starts to arise. So you get this particular pattern here. It pretty much alternates between the even terms, and you get something like this. And then you can imagine what goes on, but I'm just going to put the rest of the Taylor series here. Right, oh, that's not a 6, that's an n. So if you want to get really approximate for cos, you would keep going, but for now, let's just see why this works. So we're going to pop over to Desmos real quick and just graph these terms here.